this one. One of the things that we do is we try to get as long of a chain of atoms as possible. And so when we look at this, let's start off with that carbon now, the first carbon, and then we have a hydrogen. And so we're going to try to put as many in the plane as possible. So the first one is going to be down here. So we go carbon to carbon, and then carbon to nitrogen, like that. And then nitrogen to hydrogen. And so what we're going to do is we're going to start the zigzag here, starting with the first carbon. So I go carbon, nitrogen, hydrogen. All these are flat in the plane. Okay, then I'm going to wedge this out and dash this in. So this is going to be my CH3. This is going to be my CH2 here. And then how do I draw the other nitrogen and the lone pair here? Well, I have either I could wedge it out or dash it in. Which should I do for that here? Okay, I'm going to wedge it out then. And so what we'll do is we'll just wedge this out, the hydrogen, and then the lone pair is going to dash in like this. But that's kind of hard to see the structure on this. And so, like I said, what we do is we try to get this. But here you see this is a tetrahedral arrangement. And so instead of drawing it like this particular zigzag pattern, the easiest way to see the structure of this is to take this and rotate it, because I can rotate it about a single bond. I'll rotate it so that this dashed lone pair sticks straight up. And so what I'm going to do is I'm going to mimic this here. And so let's take a look at the first one. The first one, I have hydrogen going up, and then I got this kind of this tripod thing going on, like this, carbon here. And so what I'm going to do with nitrogen is something similar. You see this carbon has a bond going straight up. I'm going to put the lone pair going straight up. If I put the lone pair going straight up, then these two are in the plane. So if I have V in the plane, then that means I'm going to have a wedge coming out and a dash going in. And so if I take this, it's hard to see, but this is a tetrahedral EPG. The single bond here and this lone pair are in the plane, and then I have two. One sticks out, the other sticks in. So that's tetrahedral EPG. But when I look at the MG, what is the MG for that? What is it, Maya? Yeah, and so what would it be called? It's called trigonal pyramidal. That's what it's called. Do you see it? Do you see the pyramid kind of thing here? And so we can see it. So what I did was I tweak it like this carbon here. This carbon is tetrahedral, this nitrogen is tetrahedral. So all I did was I twisted it. And so here we aren't going to continue the chain. If we're continuing the chain, then it's a hassle, because if I continue the chain this way, now all of a sudden I'm sticking out of the board. And if the chain continues, all of a sudden it's kinked out of the board, and I got to do the chain like this. Does that make sense? And so if I'm doing the chain, I draw it like this. Let's say this continues on. When I terminate the chain, I might draw it like this to show you the perspective here. Okay, and then this is a CH2 here. And so in this type of perspective, we see the trigonal pyramidal arrangement around the nitrogen a lot easier than here. This is also trigonal pyramidal, but it's hard to see. It's really hard to see the geometry here.
So the MG of the whole thing be trigonal pyramidal?
No, we don't do the MG of the whole thing. We only do MGs for each atom.
Oh, and is that what that means?
Yeah. And so what they're saying is they just want around N. When we read the original question, it just said around N. Nitrogen atom. But in reality, we do it around each. So for example, this carbon, what's the Mg here? Tetrahedral. Angle? This carbon? Tetrahedral angle? 109. This nitrogen? The Mg? Trigonal pyramidal angle? Well, just the ideal, the before distorting. This angle 120 or 109? 109. And then of course the lone pair takes up more space, so it's going to compress the angle. The angle is going to be close to 107. So what we want to do is we just want to get it the correct one first. Okay, now what we're going to do is we're going to do something called amino acid. Amino acid is a you see organic chemists like to write things in shorthand. You know, organic chemists will get tired of writing the atoms out. Like this chain, do you see the zigzag chain? This is the zigzag chain right there. Then it goes to oxygen, carbon, 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 oxygen. They don't even bother writing the carbon out here. You know, there should be a carbon here. There should be a carbon here, but you get tired of writing them. Let's go to a very long chain. Let's go to some fats. Fats, the chains are extremely long, so let's pick a fat. Do you know any fats, fatty acids? Oleic acid. Do you see how tiring it gets? Do you see the zigzag chain? It's just easier to write out the zigzag chain rather than writing the whole thing out. So if we see the zigzag chain, then we know well, this is going to be carbon here. This is a trigonal planar. This is going to be tetrahedral. Tetrahedral, tetrahedral, tetrahedral. So we got CH2, 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 CH2. This turns out to be a CH. CH2, CH2. So at the end, we're going to have CH3. So it's just a zigzag. It's a lot easier. And so this is the origin of the zigzag. You know, we're developing that zigzag. This is why we try to keep things in the plane and not tweak it out of the plane. Because if we tweak it out of the plane, then the chain tweaks. You see, this one gets tweaked here, but they fold it back, so it's in the plane. So it's a lot easier to draw just that way. That's oleic acid. You know, there's like carbon loves to form. The oleic acid, how many carbons are there in this chain? A lot. But it's not even the longest. What is actually? Let's see. What is the longest chain fatty acid? These are called VLCFA. Very long chain fatty acids. They can have 22 or more carbon atoms. 22 or more. This is chloride. This is not always the most accurate. I'm just going to wait for PDF. Well, probably images are going to be the best. Take a look at this one here. Oops. Well, this is easy to figure out. This is going to be a CH3. This just shows the carbon-carbon bond. So there's going to be 3 hydrogens. It's going to look like this. You know, this is tetrahedral. Yeah. Then we've got the CH2. Do you see the CH2? We've got a carbon in the plane, and then 1 hydrogen sticks out, 1 hydrogen sticks in. You see that? CH2. Then so here's the zigzag, 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 zigzag. You see that? This is what we got here. Although they're going wrong, they should be flipped over. actually have this one upside down compared to these two. So right. At the end, we did this kind of thing at the end, you know, where we drew in the carboxylic acid group. And so we'll do one more drawing here, give you a little bit more practice with this. We're going to do glycine, which is a amino acid. Glycine, and the structure looks like this. Sort of Lewis structure. Which way should I do it? Yeah, I'm going to do it like this. Okay, try to draw that. Glycine. I think my drawing looks like their drawing there, pretty much. That's a Lewis structure for glycine. Oops, 11:42. Actually, I'm too long. Let's take a break.